Hello and good afternoon. I know it's right after lunch, and we're going to try to cover a lot of material today with you. I'm Tom Arnold, and this is Brad Dispensa.
Good afternoon. Thank you very much for having us. I want to start off by, again, thanking everyone for hosting us today. We're really excited to be able to share some of this information with you. As Tom said, we have a lot to cover, so we're going to be moving kind of quickly. We'd like to ask that you please hold questions, and after the presentation, Tom and I will be at the PSC booth to happily answer any questions that you guys have. This is just a quick summary of some of the topics that we're going to be covering today in the talk. Specifically, I'm going to focus on security in the Amazon EC2 cloud, and then give you a little bit of information about how to secure hosts and the configuration of hosts according to best practices.
And the main thing to remember here is this is for all the companies out there that are looking at doing cloud services now. You want to move into the cloud, but you want to maintain compliance, and that's what we're addressing here.
Great. So to start things off, I want to talk to you a little bit about security and Amazon Web Services. For security practitioners that are leveraging Amazon Web Services, these are some of the common tools that you'll be leveraging in order to secure the platform. I'm going to be doing a little bit of deeper information on some of these, but at a high level, Amazon CloudWatch is a service that you can use to monitor and control access to resources. CloudTrail is used for the recording of all API calls that have been made on the platform. And then I'm going to be giving you a little bit more information later on about Config, which is a newer service that gives us a single pane of glass that we can see in the environment to better understand the disparate services that are being used, as well as some automation around remediation of resources that are out of compliance. Amazon Inspector is a newer service that we launched that runs at the instance level and gives you the ability to do CVE mitigation as well as a couple other vulnerability scans. And of course, Amazon Web Application Firewall is a newer service that we've launched that allows customers to place a web application firewall layer in front of the resources. For folks that are more interested in the networking components, Amazon VPC, or Virtual Private Cloud, is used to control the network topology of your resources. And if you need to get NetFlow type data within that network environment, VPC supports what's called VPC flow logs. So the way that you're able to meet your compliance requirements on AWS is through what we call the shared security model. And what the shared security model is basically is an environment that allows Amazon to be responsible for certain areas of the compliance package, so things like the security of the facility, underlying resources, while allowing the customer to be responsible for things like care and feeding of the operating system and configuration of the actual environment. When we merge these two things together, that's how we're able to achieve compliance in the environment, such as PCI. If we look a little bit lower, this is sort of what the shared security model looks like from a more practical standpoint. And what we like to say is that basically Amazon is responsible from the hypervisor on down, and then the customer is responsible for the hypervisor up. There are a few exceptions to that rule, such as our relational database service, or RDS, that allows customers to run database environments where Amazon is actually responsible for the care and feeding of the underlying operating system, while the customer is still responsible for the security of the database. So when we think about how to match the PCI standard to securing an AWS environment, we want to look at a defense in depth strategy. And what we start with on the outer ring here is physical security. So the AWS compliance program and our attestations through SOC 1, SOC 2, SOC 3 reports are how customers are able to meet that bar. When we go into the next ring out and look at the network environment, we're doing the configuration here through controls through security groups, which is a stateful packet filter that AWS provides for all resources within a VPC. And then layering on top of that things like web application firewalls, bastion hosts, things that you would normally do in a traditional environment. And then going a layer below that, we look at things like system security. So again, not a big difference from what you've done historically in your own environments, but in Amazon, we create what's called an Amazon Machine Image, or AMI. And we want to make sure that we're always starting from a hardened AMI to begin with, so that we have the appropriate controls baked in from the get-go. And then doing things like proper OS and application patch management, as well as layering in things like identity and access management, or IAM roles, to make sure that we never bake hard credentials into the EC2 resource. We don't ever want to put API keys into a file because that's something that could be later exfiltrated. And then sort of at the center of the ring here, we look at things like data security. So this is basically making sure that we have logical access controls properly baked into the environment, proper user authentication, and then leveraging encryption at rest where we can. The way that we can get this visibility into the environment, as I mentioned earlier, is a service called AWS CloudTrail. And what CloudTrail will give you is basically a recording of all API calls that are made into the environment, and it records those and stores them into our simple storage service, or S3, which is a highly durable object store, that you can then go in and analyze after the fact using a number of third-party tools through the Amazon Partner Network. You can use Cloud Search, or even spin up an Elastic MapReduce or Redshift data warehousing service to actually go through and analyze those logs. When we want to get a little bit more granular and look at things like the metrics for the individual EC2 resources, this is where CloudWatch comes into play. And CloudWatch allows you to basically record and monitor the actual events within the AWS environment. So this is where we can go to get information around what are the performance characteristics of an EC2 resource or a database resource within AWS. But importantly, we can also do things like create custom alarms for those resources. So for instance, if I created an EC2 instance and I knew that our application characteristics looked at a certain way for I/O or network inbound, outbound transmissions, or even things like CPU, we can define a custom alarm, and then based on that alarm, we can do things automatically like terminate the resource or put the resource into an environment that can later be forensically investigated. There's a lot of data obviously coming to you, and it's hard to see that from a single point of view. So what we created was a service called AWS Config. And what Config allows you to do is have that single pane of glass to go in and look at all these disparate data sources that are coming at you and basically see the provenance of a resource within AWS. One of the newer features of Config is what's called config rules. And this is a really powerful tool for security practitioners. What a config rules allows you to do is define a steady state in your environment. And when that steady state is no longer in compliance, so an example, I've set a password policy for identity and access management users. When a user goes through and actually modifies that attribute, the AWS config rules can automatically pick up on that change, remediate it back to what the policy was, and then because we know the API call that was used to actually generate the request and who that user was associated with, we can do things like automatically lock that user out and then send a notification to the operations team to say that something has just transpired that is outside of policy. When we think about just general best practices within the AWS environment, we want to look at things like creating hardened AMIs, or Amazon Machine Images, and we layer this inside of a VPC in a security group. And remember, that security group is that stateful firewall. A best practice that we see for customers that are really focused on the incident response side is creating separate accounts. So here you can see on the screen we've got account A on the left-hand side and account B on the right-hand side. And what I'm doing is flowing the logs from the EC2 resource into an analytics store like Splunk or the Elastic ELK stack, Elastic Log Search Kibana. And we can also do things like take our CloudWatch and CloudTrail logs and funnel those into a separate account so that if there is an insider threat event, that account can be safeguarded and escrowed separately so that that third party can't see them. Just really quickly, a common misconfiguration that I see in the AWS environment where customers are starting out is that they break the solid rule of only users are allowed to get API keys, so we only give API keys to users. When we create resources, we create roles. So things get roles, users get API keys. So never hard bake an application API key into your environment, because that's a great way for an attacker to then leverage that key and exfiltrate it. So I want to switch over and hand things over to Tom to talk about preparing for an assessment.
The information that we're providing here today comes from several forensic investigations that have occurred for our customers who've been operating inside the cloud area specifically. I want to talk about basically that a cloud assessment and preparing for a PCI assessment, there is no magic to it. It's just not all because you're in the cloud, certain things are handled for you. Almost all of the 12 major requirements are represented on this slide, and they all apply to companies that are working within the cloud. You'll notice that there's only one of the 12 that's missing. Hopefully you can see which one it is in there. As far as preparing for the PCI assessment, let's look at some of the differences between a traditional PCI assessment and a new one. First off, firewalls still exist. They may be called AWS security groups, but the security groups can be configured to do absolutely everything: ingress, egress, and DMZ control. And so that's a very important point. Furthermore, the security groups will do all the logging for the firewalls. If you configure it to do so, it will put those logs in a bucket within the S3 environment. That is extremely important to do for PCI 1. Network segmentation is also fully functional inside the cloud. And you just have to configure it, and you have to describe it in your standards documents as to how you're doing it. The approach to system hardening is different. You're hardening basically a master image of the instances. The instances are now being spawned as they're needed behind load balancers, behind other technologies. So again, your standards for how you harden the system and what you do to the system is actually quite different. Also, using the AWS Config tools, as Brad brought up, is extremely important as well, specifically there. Protection of stored data. Within the Amazon environment, they have full access to an HSM, which is a hardware security module or a secure cryptographic device. So your keys can all be stored in a hardware security module. This is something that's more difficult to do when you're doing it on your own. You can have full control of the key management functions. It's just slightly different how you do things. So your standards, your processes, and your procedures will be slightly different as to how you do things. But for me, the auditor coming in, or the forensics examiner coming in, you can demonstrate all of these things taking place. Transport security, exactly the same as to what you're going to be doing there. And then finally, anti-malware and the like. Now, the problem that occurs, and why we get involved forensically, is because of the applications. It's because of flaws in the applications that specifically cause a compromise to take place. It is the area of #1 exposure when you're dealing with the cloud. So everything that's in the PCI standard in Section 6, you do need to look at, and you need to look at it very strongly. And you need to look at it as to how you detect a problem that might be there. Access controls are, again, the front line of defense. With any system, whether it's co-located or it's in the cloud, you can do stupid things. You can set it up so that somebody can access the site remotely from anywhere. But if you do it properly with two-factor authentication, you do it properly by locking in the source systems that are allowed to access it remotely, you can actually have a stronger security posture than you can on your own. Logging and monitoring, all the security controls, the procedural controls I already described are going to be different in the cloud. So now I want to talk about one area that's very, very important and near and dear to my heart. Incident response, when you're dealing with any of the cloud services, is actually radically different as to how you actually approach incident response. And what I'm talking about incident response is when you think you've had a security problem and you want to go figure out whether or not you need forensics. Or you may have a forensics investigator who's retained and standing by, but you still have to survive the first 48 hours. So if you look at this log extract from a real honest-to-God customer that was sitting out in the cloud, you're going to notice a few things that are intriguing in there. That admin access that's at the bottom is coming from a source called localhost, but it's a remote access. What's going on here? So the real story is there were 15,000 unsuccessful login attempts just prior to that. That's just showing you the real login attempt. And then they got in. They installed basically what was called a web shell inside there. They downloaded, they actually used that localhost connection to escalate their privileges so that they could modify your application code so that every time a customer clicked on the Buy It button, it went to that URL. And that is the real URL. I decided not to blank it out. That actually goes to China. Then there's this. This is a distributed denial of service attack. Amazon's one of the few institutions that is uniquely capable of dealing with a distributed denial of service attack. They have so much in the way of resources. So if you have a situation where you get an email like this one that is real, that says, you know what, guys, if you don't pay me, we're going to attack, it's time to call Amazon and say, I need help, what should I do?
And our support engineers can help walk you through how to best mitigate that and give you options around whether or not you want to basically outscale the attacker, or if you have the more detailed information about what they're going to do. Oftentimes we have intelligence that'll help us basically mitigate that threat.
Now, when I go in to do an audit, I frequently get a question with incident response that says, what exactly is an incident? Have I really had an incident? You know, the legal guys have their definition, everybody else. This is a classic definition. And I want you to pay full attention to any violation, policy, law, or unacceptable act. That's it. You know, yes, PCI says, you know, if you've got a potential breach of cardholder data, you need a PFI investigator. But this is a security incident specifically. And I just want to give us a baseline. So as you're preparing for an incident response, and let me just point out that I published a white paper with SANS Institute. The white paper is available at our booth that covers specifically incident response in the EC2 cloud. And it covers the topics that I'm talking about here, even though I'm covering it in a very fast way. But you have to, your planning objective is you need rapid detection of the incident. You need to understand the nature of the threat. And this is the one that everybody misses because every CEO goes, oh, just pull the plug. All right? You need to minimize loss or destruction. You need an initial short-term mitigation plan that says, you know, what do I do? Okay, and then you have to implement clear first response. When I say this, this is the first 48 hours. This is before the heavy-duty forensic team drops from the helicopters because you've got to survive that 48 hours, and you have to do it right. And then you've got to complete short-term containment, and then finally, you have to restore and recover. So the planning is basically there's influences on the plan, and the environment is very dynamic. Now, I have to ask a question. Can a first responder adversely impact what goes on? Yes. If you tell the Amazon environment to terminate a system, all evidence goes away with that system. So the first response of the CEO is pull the plug, rebuild the thing. Okay, system administrator terminates the thing. But then when he reinstalls the system, he reinstalls exactly the same vulnerability. Bad guy already knows where to go find it. Boom, compromised again. So first thing is realize that Amazon is one of the richest, most robust cloud environments with the number of services that they have specifically. It allows a cottage entrepreneur to act as a Fortune 500. And in the paper, specifically, realize that the weaknesses are still humans, and they're still the applications. So the reality is you must establish a detailed plan. This is an example from the paper of a step-by-step plan that says do this first, this next, this next, this next, when you're dealing with a cloud environment. And it is really quite different. So in closing, when you're planning for an incident, today is the day to have a well-documented plan as to what it is you're going to do. Agree now that security incidences occur. They will. And agree that with your lawyers, agree that with your management. Agree that you're not going to take an action as a first responder until you understand the nature of the threat so that you take a correct action, because the correct action may be to sandbox the environment. Crypto ransomware, which strikes all over the place, if you start taking that off the network, it'll start hiding itself. It'll start obfuscating the code itself. But if you sandbox the system and allow forensics to take a look at it, we have a chance of actually knocking the thing down. Anyway, last remarks from you, Brad?
Sure. So what I really want to stress is that the differences between AWS and a traditional environment are not so great. The same rule books apply, just as Tom mentioned. You want to make sure that you have a strong red book in play that you can actually go to in the event of an incident actually taking place. This is not a good time to decide whether or not you're actually ready to actually respond to an incident when an incident has actually occurred. You want to have a clear outlined process in place beforehand. For everyone in this room that has an AWS account, whether or not you know it, you actually have an account manager and a solutions architect like myself that's actually associated with your account, and we're free resources. So we absolutely encourage you to please reach out to that team, and they can help you at no cost to go through and look at your environment and make sure that you're actually complying with security best practices. It's also a good idea to have that contact because, as Tom mentioned, you know, in the world of security, it's not a question of if, it's a question of when. So that when something does actually transpire, you can reach out to that team immediately, and we can work with you and our abuse department to help you make sure to mitigate the total loss of your environment.
And so as a reminder, between 3 and 3:30, when you take your networking break, we're going to be at the PSC booth, the two of us. If you want to come by and just say hello, or you want to disagree with us, or you want to ask a question because something's burning. And this is a very technical topic with a ton of tools that we've talked about today. And we've gone ripping through this thing in 20 minutes which to some people would sit there and go, wow, I really want to learn a little more about AWS Config. And as an auditor, I want to understand how AWS Config helps me figure out that your environment is configured properly and that you're configured within the PCI standard, because it also helps us as the auditor as to how to audit the system itself. Also, please be aware that this is an important little announcement from us, but we've established, because of the number of an amount of work we've done, but we've established forensic substations now within Amazon worldwide in their regions. And that's basically to provide complete and fast and rapid incident response to any challenges that are occurring within the cloud environment. Also remember the one takeaway, applications first, second are humans. Thank you very much today for your attention.
Thank you.